So when you go down there, you should have down on the taskbar. Then here you should have this little thing that's got the little ladder on it. This is what they use for RS Logic 500 ladder programming. Now there's several languages we can program PLCs in. Probably the most popular and probably used well over 90% of the time is ladder. We'll introduce y'all to the function block in other classes, but we won't do any of that programming here. So what they've done is they set a path up for people who come up through programming. Computer people, understands Pascal programming languages. If y'all have heard of that language before, so they have a language called structured text languages, which is basically very, very similar to Pascal. So you got these people that come up through computers, then they have a language that they wouldn't have to learn ladder logic to do what? To program a PLC. And then you have a language called function block programming, which basically where you use symbols to program, logic symbols like ands, ors, nands, nors, nots, and you program it with the symbols instead of the context. Those would be for people that come up through electronics and through digital and stuff like that and haven't had PLCs. We have one, I'd have to look up the name of it. It's basically flow charting. It's a really cool language. I played around with it a little bit, but it's another language that would be available. Of course, the predominant language and the language we teach is called ladder. Every one of them that I know of supports ladder logic. So a lot of times when you start off, you have to select the language that you want to program in. So most of the time, by default, these PLCs will default to ladder. So here's RS Logic 500. If you don't have it, then you can go to the Start menu, and then you can go to All Programs, and then what you're looking for is RS Logic Software, and then right down here is RS Logic 500 English, and then you can open it right here. But y'all should have a shortcut on there. So this is your screen. We've already looked at it, right? Okay. What's the first thing we need to do if we need to put, first, we're going to create a new program. We need to make sure the application is offline, right? But okay. And then what do? We just go here, new program, and the first thing it wants me to do is what? Select the CPU. So this is 1100B. Yep. What's that? Well, we're not in the file number right now. We're selecting the CPU. What you have is on the modular PLCs, it's usually in the door. You open up the door, and then there's a label on there that gives you the CPU. On your fixed PLCs or your hybrid PLCs, it's going to be on the side. Okay. Okay, so here there's a label. Most of the time it's actually silk screen and painted onto the side. Okay. That's a really good question. So on this guy, where's it going to be at? Yeah, it's down. You look at the CPU and it's down at the bottom. So if I look at the label on the side, it says this is a model 1100 and it's got series B on there. So I'm going to come down here and look for the model 1100, get into my compact logic, so I think I went past it. And so it's 1100 series B right there. Are you okay? Now, if this is a hybrid PLC, which means what? We can add modules. Well, if you do have modules, the next thing you would do is you click on this, and this shows you all the modules that's available for this PLC. Over here on the right. So we got a AC input that can run between 79 and 132 volts. We got an analog 8-bit volts DC, right? 8-bit input, 16-bit. See that? And this would be the actual model number that when you bought it, that would be the model number that you bought, right? That makes sense. Of course, I don't have any on the side, right? You understand that? So I don't have to add any additional modules. Now the 1100 that some of y'all have that's in the little suitcase, that is a true fixed PLC. And the big disadvantage of a fixed PLC is what? But they're very cheap, but you get what you pay for. So the 1000s that we have, those are fixed PLCs. Are we okay? Make sense? Okay. And then this would be what you put it in beside that. So this guy right here can handle up to what? 3 additional modules. The little Micrologix 1200 we have can have 8 of them out there on the right hand side. So we don't have to do that. So this is, so first thing you would do is select the CPU, and then if you got additional I/O, the next thing you would do is do what? Configure your I/O. Is that okay? Everybody okay? Okay, we call this to what? Project 3. These are all your data files that the test question was asking about. Right? You understand? Okay. And the book talks about the output. So here's your bit files for your outputs. By the way, later on in advanced PLCs, and we get in some really high level commands, you can output to a whole word. And if you output to a whole word, then you can update all 16 outputs of these at one time. So that would be some really fancy stuff, right? So if I was going to try to make a sign that rotated around and I wanted to turn them off, then we could output every time and turn them off and on. Of course, this guy here don't have all these outputs. All it's got is, this has got 6 outputs. Here's my inputs. So this shows us my state of my inputs. Why ain't they changing? Yeah, I got to go online. We don't have to run it. We just have to go online. And as soon as we go online, this is the program that's already in there. But so now if I come over here and change my inputs, we can actually see it change states in the data file, right? You'll see, so this is input 0. Here's input 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's all this guy here has on it. This guy here has 10 inputs on it. Oh, okay, that makes sense. So this is a program that's already in here. We're not going to get into these instructions here. This is what we'll get into. So last time we used this PLC, it looks like when we were teaching advanced PLC. So right now I gave you an opportunity. Right now it gave you an opportunity that where you could upload it from the PLC. So if you got a PLC out there and you want to keep a copy of the program besides on the PLC, right? You understand? And what's one of the first things, if you don't have a copy of it, what's probably one of the first things you should do? You gotta go ahead and upload it and save it somewhere. And then if the PLC crashes and you gotta replace the PLC, then basically if you buy the same model, then all you would have to do is what? Is just download it. You know, those are backwards. So when we send it from the computer to the PLC, we call that download. So the PLC considers it to be the boss. And if we're bringing it from the PLC into our computer, we call that upload. So that's backwards on what you're used to on the internet, right? You understand that? So we'll go offline. And we don't want to save that. And then we're going to create a new file. Oh, sorry. So we'll create a new file. We're going to close the processor. The processor's name is untitled. You can name the processor what you want and that stuff. And we're not going to save the changes to this. So first thing I need to do is what? Series B, right? Where's that information at? I'm going to tag over here on the side of the CPU. And then we're ready. So what we have access to now is we have access to the palettes of instructions that this PLC supports. So that's one thing it gets when you select the processor type and the version type. It gives you the palettes of the instruction that the PLC supports. So these are user instructions. These are our commonly used instructions. And these are bit instructions, timer counters, input, output. This is actually sending messages, by the way, which we're not going to get to. Compare instructions, which we'll get to in PLC2 if you take that. Program, this is our math instruction that's available with this PLC. This is where it really starts varying a lot. As y'all can see the little thing, so it'll add and subtract, it'll multiply, divide, it does square root, it does negative numbers, it transfers, it converts BCD to binary, and it converts binary to BCD. So a lot of times you're over on a touchpad and you want to enter the speed of a number, you're not going to enter it in hexadecimal, right? Understand? So you entered in decimal, it transmits BCD to the PLC, but you want to process it with math, right? You understand? So what would you do? You would tell your PLC to convert it from BCD to binary, and then before you send it out to your display the speed, you want to convert it back to BCD. Most of your displays run off of decimal, right? You understand, or BCD. Here's all our move and our logic instructions. So this does a move. It does a move with mask. It does an and, or, a nor, not, and it does a clear. These are our file control and miscellaneous instructions where we can play around with fields and stuff like that. Shifts, program controls. You can see the list just keeps going on. ASCII string. So this is where you could actually send ASCII to a display that runs with ASCII code. Over here, there's a lot of displays that run off of ASCII code, right? You understand that? So it will convert numbers over to what? To ASCII for you, so you can send messages. And then high-speed counters, which we won't get into this minute. Trig. So this guy, it's got trig, but notice all of them's grayed out, which means what? This CPU doesn't support it. It doesn't mean it doesn't mean if you got it on the 504s that I think the 504 supports all these trig functions. So that's one of the things when you buy a processor, or when you buy a PLC, you need to make sure the version that you get supports the instructions that you need, right? You understand? And then advanced math. This does do absolute values. I'd have to look these up. Engineer notation. I'd have to look those up myself. So that's your instruction palette across the top. Siemens puts theirs on the right. Allen Bradley puts theirs where? On the top. You got to scroll through them, kind of, unfortunately. Well, sort of. We do have an instruction palette, if I can remember what's that. No, that's not it. Yeah, this is the instruction. So this is the instruction palette right here. So this is all the instructions that the ones that are not grayed out. These are all the instructions that this PLC supports. But you gotta know the mnemonic for them, right? So this is one way we could do it after we use the PLC for a long time, is I could come up here and put that up and I can grab them, move them in right there. And this makes it a lot faster, but you gotta know what these little mnemonics are, right? Like INT and all those kind of stuff. But after you played around with this same PLC for a while, believe me, you'd learn. And it's a lot faster to use the palette than it is to do what? And try to find them, scroll through that menu. But that's available on this PLC. So now we got to go all the way back to users. By the way, it doesn't roll around. So if you got, and it don't scroll, so it means I don't think it does. So we started a new one. We're going to come up here and we're going to put a normally open. We'll start off with a normally closed. Then we're going to put down drop. And then we're going to put a coil. Everybody okay? That makes sense. You can copy and paste these things, guys, as long as you don't have it assigned. So if you know you got to put this many inputs and this many outputs, so you can come up here and what's the shortcut for copy? Control. Now you got to work from the outside. What you need to do is work from the left to the right. So if I wanted to copy this one, I could click on it. I can hit Control C. I could come down here and highlight that and hit Control V, and it pops over there. So if you got RUMs that are very similar, this is a real fast way to do it, to go ahead and put the circuits and then come back and address later, right? If you want to delete it, you just highlight it and it turns around there, and you hit what key on your keypad? Delete, and it's gone. If you want to delete the RUM, you just come over here and highlight it and hit what? Delete, and the RUM's gone. All right, you understand that? Everybody okay? So we still have errors. What do we need to do now? Assign addresses, right? Okay, now this is a fixed PLC, right? You understand? So my inputs are at slot 0 and my outputs are at slot 0. That makes sense? So I would say what? N. All right, that's my type of instruction. I'm going to put what? Colon, right? Then I'm going to put the slot number, right? Okay? Okay. And then I'm not doing a word. I don't have multiple words. And I put a what? /, right? And then I'll put 9. And this will pop up. If you hit enter, if you just click somewhere else, it'll stop right there. If you hit enter, what's it giving you the option to do here? You can give it a comment, or comments are great, but what we want to do is get used to assigning a what? A symbol name, right? Because I said this is going to set you up for PLCs that are out there now. PLCs that are out there now don't call them symbols, they call them what? Tags. Call them tags. So N:0/8. And then we'll call this gator stop. Now in motor controls, and don't ask me why. In motor controls, we usually put the stop on the L1 side. On PLCs, they usually put the stop after the ceiling. And this is just the way they like to program. This is definitely the way they do it in Germany. Output, colon, don't ask me why. Okay, then we didn't assign it a symbol, right? But if I want to go back and do it, I say, okay, I needed to assign that a symbol. I skipped over that, right? You understand? What can we do? Right click it, right? And then choose what? No. Yeah, I had an error. You know what I did? What everybody here is going to do. Okay, and then we need to assign this. Now I can come up here, instead of having to remember that, I can just type in one. I can just type in the symbol name and it'll automatically fill in the address form. Okay, what's the next thing we need to do? Not yet. What we need to do is we need to go ahead and check it for syntax errors to make sure it's going to compile okay. And so we come up here with this little computer with the check mark on it, and we do what? We click on that, and if everything goes away, then it means you got things in the right syntax, which means it's written right, right? It doesn't mean you use the right contact number. It doesn't mean that, or the right input number. It doesn't mean that, as long as it's checking the right syntax. Okay? Everybody okay? Now, for some reason, Allen Bradley actually puts the model number down here of the actual PLC or the input module. So if you're on one of the 504s, it'll actually put the model number of the input ports. I think I had it up the other day, right? Okay? And while they do that, it really don't mean anything. So we're concerned with this and this and this. Everybody okay? And then I would come up here and do what? Now I go and download it. Now this is where you need to do what? This is where you need to assign your program a name. What we're going to do, and this is the syntax that we need to use, is, and the names can be long. This is not, originally when the Microsoft Office, when Microsoft DOS was out, your file names were limited to 8 characters. But you could use some punctuation. You couldn't use all punctuation. You could use some punctuation. Now that seems like a lot. So you say, well, I got 8 digits of base 10, so that's 10 to the 8th combination, right? So that's what? 100 million combinations of that you could have, right? You understand that? But the problem is that you tried to give it a name that related to your, and I'm laughing because we had an instructor here that he would name his files like ping pong and stuff like that. And you'd come back later on and you had no idea what it was. What did we have to do? We had to open them up when Paul retired. So this is where you'll give your program a name right here. This is where you'll path it. So this is where you're supposed to have your thumb drive, right? Understand that. And this is where you would path it right here. So you come up here at the top and you'd find your thumb drive. Now what we're going to attempt to do is we're going to attempt to put it on our server. And that way at the end of the semester, I can delete them all, and I'll show you how to do that. So what do we want to call this? Ping pong? I'll do that in honor of Paul. And then I think on my desktop, I have a PLC, and then I've got Allen Bradley, and then this is where I'm saving my programs. So this is the way you get the little RSLogic icon on the side of your program. Then you get the name of the program and then the extension. If the extension is turned on the computer. We're okay. And then it tells me I want to do what? Download the program, right? It tells me that the processor's in run mode. Now these guys, it's automatically, on this guy, it's going to automatically switch modes for you. That guy over there, you got a switch that says run. You got a switch that's called program. If you got it in program, it allows you to upload or download a program, right? And then you have to remember to switch it to what? Run. It's got one in the switch called REM. What do you think that stands for? Remote, which means it would work just like this. So if you have it in the remote position, then it's going to ask you these same questions that I'm getting ready. It's up to you, whichever you want to do. Most of your newer PLCs have that switch on there, so that way, I think I told y'all that, is you can do what? You can switch it to run and then do what? Take the key out. And then nobody else, they can't do what? They can't program it, right? They can't change program. So we're going to switch to the run mode. Then it says change back to the run mode, right? We'll change it out. Then it's asking me, do I want to go online? So when I go online, it means I'm going to be able to monitor what's going on this thing, right? Okay, so this is the way this thing shows me. So it shows me this is, I'm ready for this. But what's the problem with that? We're going to demonstrate this too. This is an examine if open. The one on the left is an examine if closed. This is examine if open. Now this, if it's an internal contact, you don't even think about this. It's only when you're putting these guys from a input port, right? You understand that? It comes from an input port. That's when we got to deal with examine if open, examine if closed. So right now this switch is open. And I'm using an examine if open, so it says it's true. So we come up here and we should switch, we should switch switch 9. And it should, now this is this guy has momentary contacts on it. And this is what we're trying to simulate. We're trying to simulate what you would run into industry, which is a push button, right? A momentary contact push button. Okay. Everybody okay? I have to go get you some water. So what we're going to do is we're going to try to wire this up. We're going to run the motor. I'm going to wire it in yellow, so I can take that here in a second. So here's, let me get my camera up. This is what we like about this trainer, or this module that we mount our trainers on. It gives us the ability to actually wire the inputs and outputs on it. Okay. So here's my inputs. So I can use these switches, or I can set the switches in the center position, and then I can actually wire my inputs in here. So this will be input 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Everybody okay? We have this guy set up I have my input set up for syncing. So that means I have to wire my input devices to source, right? Okay. So we'll do the outputs right now. So I have my outputs set up to source. So I'm gonna have to wire my devices to do what? Sync. That makes sense. So what I'm gonna do, over in Germany, by the way, I deliberately tape that up because that's a really, really bright LED. So my output ports are sourcing, so I'm going to set up my device to sync, right? Understand? So that means I'm going to take this negative right here, which is blue, and then I'm going to run it out to one of the commons of my motor. Now, it won't hurt anything. Depending on DC motors, depending on the polarity that you hook up would determine the direction. So right now we'll just go to black. Now what I would have to do now, if I had multiple output devices, is I would just keep taking this yellow and I would just connect it to a common on everything out there. You understand that? Okay. And then what I'm going to do is I'm going to come over here to my output port, which is output port 0. And we'll turn this off. I need to turn my PID, yeah. So I just turned off my power supply. And here's output port 0. I'm going to hook that up. And then I'm going to come up here to the motor. And that's all there is to it now. So what I would do is I would run a common between what? All my output devices themselves. And then I run the common out from my minus common, because my outputs are set up to do what? Source. So I'm going to set the devices that I hook up to my ports, I'm going to set them up to sync, right? Everybody okay there? So the motor should come in and run. Stop right here. And here's my stop button. Here's my stop button. Okay? You can't see my motor running. Are we okay? And here's my stop button. And it's momentary, right? I understand that. But the problem is, I don't know if y'all are looking, since I'm using an examine if what open, I have to use a normally open switch for my stop button. Well, okay. So I'm going to disconnect the outputs because I don't have enough room over here. And what I'll do now, because y'all know the motors are going to run, right? So all my output devices, I would just take, if it's set up to, if my outputs are set up to source, I would just take that negative and just jump it to every one of my output devices, right? As my common, right? A negative common. Now my input ports on my PLC are set up to sync. So it means all my push buttons I'm going to have to set up to do what? Source, right? Okay. So what I'm going to do here is I'm going to come over here and I'm going to go to the positive on my output, on my guys. Let's turn this off right now. And then here's my push buttons right here. Okay. So we're using normally open push buttons. So I'm going to hook it up to common here. And we got two push buttons. So what am I going to do? I'm going to just jump it over to what? To another push button. So all my input devices, if my ports are set up, my input ports are set up to sync, right? You understand? So what I'm doing is I'm making the positive common for all my input devices. Okay? And then I will take this guy. I don't remember which is which, but it don't make any difference. And I'm going to hook this up to input 9, which I can't see. This guy right here. And then I'll take another, and then I'll hook it up to input 8. Oops. Yeah, so hooking up the PLC itself is not that complicated. As soon as you understand how to do it, it's real fast. I could probably, we got some over there. These guys right here, I can wire these in about 15 minutes into this panel right here. Turn it back on. And now one of these should be my start. That's my stop button, right? Oh, I'm sorry. This is my stop button right here. Okay. The motor's not running. So all we're doing is looking at this. Okay, so that would be the motor running, right? You understand? And here's my stop button. So this is the stop button. This right here is the stop. Now this is the problem in motor controls. As soon as I get this thing to, there we go. So in motor controls, we would use a normally closed contact. We would use a normally closed push button. And this is what gets students coming out of motor controls. This is what gives them problems, because they take a motor control diagram and they convert it over to a PLC data, and they're using a normally closed push button, and they want to give it a what? A normally closed symbol, right? You understand that? Now this is the problem right here. So this is my stop button. Right? Yeah, this is my stop button. This is my stop. Stop, start, and I'm going to simulate breaking this wire right here. Now I can't do what? I can't start it. I can't stop it. Right? Y'all understand? Yes or no? Because it's an examine if open. Well, what's the problem? The PLC sees it as what? Open. Right? Y'all understand? So this is what we get back. Right? So this is why when we come in and now I can stop it. So what do we need to do? So I'm going to go back to what? Offline, right? Yeah, okay. And then I'm going to come over here and I'm going to change this to what? So I'm going to come up here, I'm going to edit, not the symbol. Edit, change the type, right? And I'm going to change it to what? Examinative close, right? Okay. We're going to come up and check it. And what I'm going to do is I'm going to move it to a normally closed push button. We've only got one normally closed push button on my panel right here. So we download it, right? Check for errors, download it. We modified it, so it's telling me that we want to give it a revision number. And we'll see if I'll go back online. And of course, now I can't do anything with it. Right? You understand? Unless I hold this closed, right? You understand? And then I could press the button. Are we okay? So what do we need now? Now we need a normally closed push button. So what I'm going to do is I'm going to change this common. Let me put my camera back up so you can see what I'm doing. So I'm going to take the common that was going to my stop button, and I'm going to move down here to a true normally closed push button. Which the caps broke off of it, by the way. And now it shows us what? Shows it's true. So now I can hit my start button, right? And it does what? I might need to hook up the motor so I can hear it, but you can see the output. And I come over here to the stop button, it does what? Stops it, right? Here I hit the stop button and the wire breaks. What did it do? The motor stopped, right? So this gives people some problems. We do have a little problem on the 1000s. So on these guys, you can simulate a normal closed. This guy here is about normal closed contact. You just simulate a normal closed contact, like just leave the switch wide on. The 1000s, all the push buttons on the trainer are normally open. But what they have on the right hand side is they have a selector switch that you can simulate a what? Normal closed. Okay. So we look at one of our first labs. I think it's like I said, I can run off a few labs, guys, and there's a lot of homework labs that we're going to have to do. Some of y'all can go ahead and start working on if you got the lab book. If you don't have the lab book, then you'll have to wait until we get them, because I can't run off a lot of labs and still not get in trouble, right? But I can run this one off. I think the first one that we're going to actually program on the I think it's 6.2. And this is our first programming lab. Very, very, very simple ladder diagram, right? It's only got one rung, got 2 lines, right? Has absolutely no relays in it, but it's got lightning. So what does that mean? I'm stuck in here. I got all these cords behind me in my chair. So that means we're going to have to use two output ports, right? You understand? It gives you the symbol that you're going to use. One of them you're going to call red pilot light, and the other you're going to call what? Green pilot light. Your two switches, your two inputs, you're going to call them what? Switch 1 and switch SW1 and SW2. Are you okay? So I'm going to program it up here so y'all can just get an idea what it's going to look like. I don't have it. Anybody turn to the lab so y'all don't. So I'll make sure we do this right. So what's the first thing I need to do? Yeah, I need to go offline, right? Then we need to do what? We need to go new right here, right? And it's going to ask me, do we want to check, close out the processor? We're going to say yes. Next thing it's going to ask me is what? Yeah, select the CPU. Okay. And then we're going to click on this. We're going to insert a what? A rung, right? Well, how many rungs do we need? One. We got two normally open contacts. And then we're going to have to run lights, right? You understand that? Okay. So then we have a down drop that's right in here somewhere, right? And I think one of the contacts are inside the down drop. By the way, don't grab it at the top. Come down and grab it toward the bottom. Right? We okay? Okay, what else? Where's this guy at? Is it in, this guy right here is inside the loop, right? Like that? Is it like that?
Yeah. And then you had another load on the bottom.
I should have drew it out.
Just give them the drawing. Like how that goes all the way over. It still means the same thing.
L1, these guys right here, this is not drawn exactly right. This green should be over there. But undoubtedly, they didn't want to intertwine these.
Yeah.
And they wanted to save room, so the symbol, they put it over toward the left. But see, there's nothing between this guy and L. So where does your loads go? Your loads go on to L2, right? And then your inputs are between L1 and the load. So we got a switch right here, we got a switch right here, and then we got, okay?
Yep.
So is that it?
Yep.
That's it. Here we're going to assign it an input. So remember, if you're on the 504s, your input module is 1, right? You understand? Your output module is what? 2. If you're on one of the 1100s down there, or if you're on one of the 1000s, then those are 0. Your inputs are 0 and your outputs are 0. And what do we call this? SW1, right? Okay. And then this guy right here, this is going to be input. We'll just go right down the line, right?
1, 5, 1, 0, 5.
Yeah, sorry. And we'll call this SW2. 2, Rick. 2. And then we'll call this guy here we'll give it address. We'll go output, and we'll just assign it to output 0. By the way, so what I did is I went away from it without hitting enter, right? You understand? So what happened? It didn't give me an opportunity to assign a symbol. So what can we do? We can right click on it, go down and do what? Edit symbol. Oh, not instruction type, Rick. Right click, edit symbol. And we're going to call this in what? Huh? RED underscore LT. PLT. And then we'll assign this output colon 0/1 enter. And then this is called green. GRN. By the way, you can use lowercase letters, but you notice what happens. It automatically gets. So this is our program, right? Okay. What's the next thing I need to do before I download it? Okay, we check it for errors. We'll come and check syntax right there. Everything looks what? Okay. What's the next thing we'll do? Yeah, we'll download it into the PLC. Assign it a name. -1. I think no, it's 6-2. We'll come in here and select a location. And it says, do I download the program right? Then I'm we're in the run mode. What's it going to do? It's going to switch it, automatically switch it to the program mode. And it wants to know if we want to go back and go back online, right? Now this will be exactly the same thing on the 504s if you have your switch in what? Remote, right? Okay, you understand? If not, you're going to have to switch it between what? Program and run. But like I said, that's your call. So there it is, guys. So of course we don't have any lights hooked up, but we can come up here. So when we hit switch 1, what should happen? Green should come on. When we hit switch, when we hit switch 0, the green should come on. When we hit switch 1, the red will come on and the green will stay on, right? Everybody okay? Y'all see that? So we need to rewire my PLC. So we're using 2 normally open push buttons, right? So I'm going to take my common and go back to another normally open push button. And I'm going to jump this in here. And then we're using 0 and 1. Let's see if I can see it. So press the switch right here. The green light would come on if I had it connected up right. And I press right there. So I'll let go of the first switch, they both go off. And that's the first very, very basic program. I got green and red lights on the other one where we could actually turn them on. So here we're actually using inputs and using outputs. Everybody okay? Pretty simple. See how to wire the PLC, right? Everybody okay? Wire it to actually your devices. Because I think every one of these is going to come up and ask you to show you how you would go about wiring the PLC. So I still have it up. So this is the way you would come up and have to do what? Wire it. Now they've got a little problem here. Can somebody tell me what the problem is? His problem is he's calling this plus 120 volts AC. Now normally out in PLCs, what you have is you'll have a common and then you put, and it wants you to either use an internal power source, but most of the time now on our input devices we use external power source. And why? Because we're in automation today, most of your sensors are solid state. And you could very easily overwhelm a power supply that's inside of a tiny PLC. So normally what we would do is on those, so most of your PLCs now, if I can remember how to get it up. So most of your PLCs now, this right here would be labeled common. And then what you do is this is where you would put your DC voltage source. So on this one, we would put our negative. So y'all know the symbol for a DC voltage source. This short line represents the negative and the long line represents the positive. And that's where your DC source would be over there. So notice I have the positive pointing, it's the common for what? My two switches, and then I'm telling my input for that I'm using a minus, right? You understand that? Now over here, since we're sourcing, this one over here is going to be like this. So now the minus is the common for our loads. See about that? And then the positive is the common for my output port. So this is the way you should get used to doing it. Are you okay? You'll need to go ahead and make that correction in your book. So all ours, every one of our labs is going to use syncing inputs and sourcing outputs. That's the way our PLC is set up. Except for the 1000. Anybody know what's going on with the 1000? I'll tell y'all. But if you got the 1000, if you get on one of the Micrologic 1000s, then this is the symbol you'd use. And what's that a symbol for? An AC source, yeah. And then over here, this would still be the same. So this would be what you do for if you're on one of the Micrologic 1000s, right? Mm-hmm. If you're on one of the Micrologic 1100s, then you would use this. And if you're on the SLC 504, that's what you do. So the 504 has got sourcing outputs, and that's actually written in the module. I mean, if you look at your input module, if you look at the bottom, it says sync. If you look at the module, it says what? Sourcing. Because the modular PLC, the power supply is here, right? This is where you got to get a power supply to run all your input. All your power is down through that backline. So up here, you value the what? Sinking modules or sinking modules. I say that twice. Sinking water source. Depending on the way your company likes to run. Predominantly, inputs when we talk in sinking and sourcing only comes into play when you're dealing with DC. It doesn't come into play when you're dealing with AC because AC does not have a polarity. You have what we call a neutral, which you got to honor because neutral is reference to Earth. Any questions? Well, they give you the ladder logic diagram, but notice here they're giving addresses 0. But if you're on one of the 504s, and I don't think anybody has to be on one of the 504s. I think we got enough down there so we can either be on the 1100s or the 1000s. Then these are addresses. If you are on one of the 504s, then your inputs are going to be module what? 1, and your outputs are going to be module 2, right? Understand it? We have people go in and see this, and they'll program it just like that, and they'll download it, and if they got problems. It'll pass syntax because it's written right. Then we're going to simulate a limit switch. So you're going to modify your program a little bit, right? And then if you're on one of the 504s, when you get over here and it says assign this to this, you're going to have to mark these out, right? Because your inputs are in module what? 1 and your outputs are on module 2. And then you need to modify this just like we did before. Okay? So I think this is, so this is 6-2, and there's 2 activities in 6-2. Are we okay? And like I said, if you don't have this when we get down to the lab, you let me know and I'll run you off a copy of this. And then we're just going to have to hold on. Like I said, I think this is 6. All the labs between this is the first PLC lab. So we gave y'all out one, the numbering systems, right? You understand? But all the labs before this are homework labs. And those are going to be due, right? So if you got your lab book, you got an advantage on somebody that don't have one, because you can start doing what? You can start working on those. Everybody okay? Yes or no? Okay. And then y'all that don't have y'all's lab book, y'all just have to wait till they come in. So that's why I'm not making them do, because of some people that don't have their lab book. Are we okay? But y'all got to buy that lab book, guys. I can't run off just these. So I'm just running off the labs where you have to physically do something. Are we okay? All right, guys, y'all ready to go lab?